In this example, we are integrating from 1 to 3. And this function has a vertical asymptote at 2. So it's really important that we recognize that this example is integrating across a vertical asymptote. And we cannot integrate across vertical asymptotes because these are unbounded areas. So what we need to do, first of all, is recognize that this is the case. We're integrating across a vertical asymptote. And then we need to set this up formally. And it's important that we split up the integral on the left side of the asymptote and on the right side of the asymptote. Now, that said, if we actually look at the diagram here, we can see that it's symmetrical, so we should end up with an area underneath the curve canceling out the area above the curve. However, we're just going to, as an exercise, go through how we should approach a problem like this. So, the first thing is recognizing that we have an unbounded integral, which means we have to set this up as a limit, and we need to set up two different limits here. So the blue area, I'm going to set this up as a limit as a approaches the asymptote 2, but we're approaching it from the negative side here, okay, when we calculate that area. And that is going to be then from 1 to 2, okay, which I'm going to put in my integral as a. And we end up with, I'm just going to write this with a negative power, just to make it a little bit easier to look at. Okay, so that's going to be the area, the blue area there. And then we need to set up a separate integral and a separate limit for the area on the right-hand side of that asymptote. Now we're going to approach that asymptote, though, of 2 from this side, and it represents my lower bound. So a is going to approach the 2, but now we're going to approach it from the positive side, and the a represents my lower bound. So from 2 to 3 is going to be my bounds, and it's the exact same integral antiderivative as I have in blue. Okay, so that's how we set it up. Now we just have to do these parts separately. So I'm going to do the left-hand area, limit as a approaches 2 from the negative side. I'm going to anti-differentiate this, so I'm going to end up with x minus 2 to the negative 2. I'm going to divide by negative 2, and the bounds of integration are going to be from 1 to 2 from the negative side. Then I'm going to do the same thing for the other side. The nice thing about this is the antiderivative is going to be the same. We just have to be careful because the limits are slightly different. I'm going to approach 2 from the positive side this time. And so I'm going to x minus 2, negative 2 over negative 2. It's the exact same antiderivative. But the bounds are different because now my lower bound is the asymptote a, and my upper bound is now going to be 3. Okay, just going to clean this up a little bit. I'm going to factor out the negative 1/2, just so that it's a little bit easier to deal with. Limit as a approaches 2 from the negative side, 1 over x minus 2 squared. My bounds are going to be from 1 to a, plus, I'm going to factor out that negative 1/2 as well here. Limit as a approaches 2 from the positive side this time of 1 over x minus 2 squared. And my bounds are going to be a to 3. Okay. So I'm going to then evaluate these limits. I'm going to plug in. So I'm going to plug in negative 2. I'm going to plug 2 into that expression. So I'm going to get a divide by 0, but since it's squared, it's going to be from the positive side. So I'm going to end up with 1 over, I can be a bit more formal here. I know this is going to be 0 negative, but from the negative side, but squared. So that's really going to be from the positive, a 0 from the positive side. minus 1 over negative 1 squared. Okay, I'm just going to evaluate this part here. So negative 1/2, and that's going to be divided by 0 from that side. It's going to be infinity, okay, minus this, in this case here, is going to be minus 1. Okay, so that's going to be positive infinity since it's approaching 0 from the positive side. And so this portion here is just going to be negative infinity. Okay, plus. I'm going to do the right-hand side now. We're going to end up with negative 1/2. I'm going to evaluate my limit. Now this time I'm going to 0 from the positive side, okay, which is not really relevant because in both cases we're going to approach 0 from the positive side when we square it, minus, when I plug in the 3, I get 1 squared. Okay, this becomes negative 1/2 times positive infinity minus 1. Okay, so this ends up being, the minus 1s actually will cancel out, and then I have negative 1/2 times positive infinity. Oops, I did this wrong. I have to flip these around. I was wondering why it's getting a little bit different results than I was expecting. So plug in the 3 first to get 1 squared, and I'm going to plug in the 2. 2 minus 2 is 0. This time I'm approaching 0 from the positive side, and then I get 1 minus infinity like this. Okay, so we end up with, this is going to be positive infinity on this side. Now these happen to cancel out because we know they're symmetrical, so we end up with a net area is going to be 0. Okay, so although both those areas are infinite, since they are symmetrical, we can say that they are going to cancel out, so we get a net area of 0.